Hi girls, let us now return to bite-sized knowledge from Mr. Andy. Okay, today we'll be doing the factor theorem. Before I jump into things straight away, okay, we'll start with remainder theorem. Okay, last time we talked about remainder theorem. It's when fx is divided by some x minus a, then fa is the remainder. To say it's a theorem, it's rather funny because it's essentially an observation. We did long division. Okay, we did long division and we found the remainder. And the next thing we did was, if you remember, we substitute a inside the function. Instead of x, we took the value and we chuck it in. We evaluated and we realized, oh, it's the same. What's left over is essentially the same as the remainder. Okay, so this observation, it's useful. But we do have an extension. Okay, and this extension is useful only when we come to an example. Okay, so we need to develop the idea further by stating one more theorem. Okay, we call it the factor theorem. Now that we know fa is the remainder, so just think about it like that. Fx is divided by x minus a. Okay, then fa is the remainder. Now what happens when there's no remainder? Okay, think about numbers. 15 divided by 5 is 3. What do we call 5 and 3? Ah, I hear you, alright? It's factors. Okay, I'm sure you know it's factors. And gladly speaking, remainder is 0. Makes life far less complicated. Okay, so even with numbers, when you divide numbers by some other number and you get remainder to be 0, we call it factors. Okay, so it's the same. We generalize this to polynomials. Okay, so fx divided by some ax minus b. Okay, I'll explain to you what is ax minus b. Alright, if fx divided by ax minus b and we are told remainder is 0, or let me write in blue, divisible. Okay, they tell you fx is divisible or fx is exactly divisible. All these mean the same thing. Okay, we have but one conclusion. Ax minus b is a factor. Do also note, this is true both ways. If given that ax minus b is a factor of fx. Okay, if given that ax minus b is a factor of fx, okay, let me just show you some working. So we let ax minus b equals to 0. You should be able to tell me that x is equivalent to b over a. Is that correct? Alright, so with that, alright, you've given ax minus b is a factor of fx, then fb over a, okay, we get from here fb over a equals to remainder. Do you agree? Okay, by remainder theorem. This is remainder, and remainder must be 0 because we talk about factors. Okay, so this is actually true in both ways. Factor means remainder 0, and we don't know it's a factor, we can call it a factor then. Okay, so with this, we start with the problem. Okay, no explanation is better than going through a problem, right? We'll go through one that requires both. It's the same question in the same page. It's not the same question, but it's another question on the same page of your TYS. Flip to chapter 3, page 18. Okay, now we are given this ax cubed. Oh, it's a minus, okay, minus 8x squared minus 9x plus b exactly divisible by 3x minus 2 and leaves remainder 6 when divided by x. Very kind question. Alright, divisor is really nice. Okay, now we are told to find a and b. Okay, so let's invoke what we just learned. By factor theorem. Oh wait. Let me try to go through something first. Okay, we all have a name. My name is Andy. I'm sure you have your name as well, but this poor function on top, let me highlight it, has no name. Poor function. Okay, normally we start with f. Alright, if f is taken, we use g. If g is taken, we use h. Okay, so f x is its name. Now it's happy. Alright, your function has a name. Okay, please give it a mathematical name. Don't call it Lily or something. Okay, now let fx be this. Okay, so now we have something to work with when we quote our theorem later. By factor theorem. Ah, shucks, I don't remember what's factor theorem anymore. Alright, let me just check. Alright, factor theorem states that when fx is divided by ax minus b, remainder is 0. So we are saying, oh, okay, this fb over a equals to 0. So we check this. Okay, so let me highlight this. Okay, this is ax minus b. By factor theorem, let me see where's the b. B is 2. A is 3. Ax minus b. Okay, so this must be 0. Oh, this is the conclusion I have to make in order to proceed on with the question. Okay, try to simplify it yourself. You're supposed to get this equation. Reminds me of something. Now I have two variables, a and b, but I only have one equation. Oh, okay, now I see. Second piece of information. Leaves remainder 6 when divided by x. Oh, so now I know what to do. By remainder theorem. Oh, This is awkward. Alright, let me try. X is just x minus 0. Oh, okay, now I know. So, it's basically telling me, okay, let me just highlight the link. Oh, it's x minus 0, so we substitute 0 into, okay, our fx. Leaves remainder 6. Okay, so what do I do? Okay, substitute 0 inside, 0 inside, 0 inside. Oh, so I find that b is 6. Hence, a is 12. Now that you've seen factor theorem and remainder theorem in action, okay, you should know what we are trying to do. Okay, whenever you're given exactly divisible by a divisor, okay, you can set it to 0 and see what you need to substitute back inside our polynomial. Okay, in this case, 3x minus 2, so we do 2/3. If it's 2x minus 3, then we have to substitute 3 over 2. Okay, and when they say exactly divisible, remainder must be 0. Okay, remember by factor theorem, remainder must be 0. And remainder, by factor theorem, remainder must be 0. But for remainder theorem, what we are trying to do, we substitute it inside and we equate to whatever value they told us the remainder would be. Okay, as you can see. Just like that. Okay, so now we will move on to an identity question that will link us to our next episode. Okay, how we deal with factorizing cubic polynomial. The question is in page 17 of your TYS. Okay, it's I'll write it down here. If you will get lost, you can refer to the book. Okay, 2x cubed, 3x squared, minus 14x minus 5 equals to 2x minus 3 x plus 3 qx plus ax minus b. Sorry, ax plus b. Okay, there's something I want you to know. There is one learning point from this question. The first one, check. Okay, divisor. Divisor is this, 2x squared minus 3 plus 6 plus 3x minus 9. Okay, divisor, check. Divisor has power 2. Power 2 divisor will have power 1 remainder. Okay, so this is one thing to take note, something I would like you to remember. It's very useful. It's considered a technique used in a higher order thinking questions that might appear in exams. Okay, when divisor is power 2, remainder is at least, okay, remainder is at least 1 degree less. So remainder could be ax plus b. It could also be 0. Okay, where there's no remainder, so it's constant, and the degree difference is 2. Okay, now this is not the main point. It is a learning point, but it's not the main point I want to go through now. It's something to do with factorizing polynomials. Okay, this is cubic. This, on the other hand, is also cubic. Okay, so from the book, okay, I shan't go through the details. You should be able to find that a equals to minus 5, b equals to minus 5. Okay, so with that in mind, okay, we have all the details we need. okay, we can do long division, and we can do a cubic. We can divide this cubic by the quadratic factors to obtain QX. Okay, let me just show you. Okay, I have this, and then on that side I have 2x squared plus 3x minus 9. Same thing, 3 terms to 3 terms, so I must start with here. First term, 2x cubed divided by 2x squared gives me x. So 2x cubed, 3x times x minus 9x. Minus 14 minus 14x minus 14 plus 9 minus 5x minus 5. Okay, so there's nothing we can do. Qx is just x. Okay, and we can write it simply as this. Okay, I hope at least till this point is clear. We have a cubic polynomial on the left hand side, and we have something factorized. We have the qx, we have the dx, we have the rx. Quotient, divisor, remainder. We have all three on the right hand side. Okay, but what do we mean by factorization? Okay, I'll highlight to you. Factorize means remainder must be 0. Okay, now this is cool. So why do I bring this up? I'm going to move, okay, I'm going to use a highlighter. That, okay, I'm going to move that whole chunk over to the left. Okay, watch what happens. Okay, minus, so you plus 5x on both sides, so you use minus 9x. Alright, check it out. Okay, fully factorized. Okay, this is how I'm going to close this chapter. Okay, this part on factor theorem. Okay, stay tuned for the next episode where we will do factorization of cubic polynomials. Okay, this is what we're going to do in the next episode. Thank you.